Okay, so hey guys, it's Quinston, and today we're going to talk about factorization, how you can factor a number into factors. Well, that's pun in, whatever. So the first thing, what we're going to do is we're going to just jump into the code because there is nothing really meant to explain over here. You have like example the number 15, you just have to find the factors. That is 3 times 5 is 15, or you have 8. 2 into 2 into 2 is, or you can say 2 times 2 times 2 is 8. There's not really a lot of depth in this program. This is the best way I know how to do it, and I think most people would agree with it. So the first thing which we do over here is we import two things. The first is the array list, and then you have the scanner. And the array list is just used to keep track of how many numbers I'm going to factor out. You can even just, when you find the factor, you can print it out, but I don't want to do that because I want some other stuff to be done with it. So I use an array list. You can use a normal array, but that will limit your capacity of how many factors you can produce. Then you have the import statement. The import statement basically for the scanner, you're going to take input from the user. Yeah, it's magic. You have to make it a static scanner object because the main function is static. So static scanner. What the? Sorry. So static scanner object. Yeah. Public static void main. Basically used to for the main function. It's static because you have only one instance of the main function and not a lot of them. Okay, then this line over here, scan equal to new scanner system.in. You're taking input from the system, that is in the console, so you have to put this in, and this is basically you're creating a new object here, and the name of the object is scan, and this is connected to the scanner class. Okay, line by line explanation, very good. Array list integer. You have to make an integer array list, an array list which holds a bunch of integers, and that is called factors. And a new array list integer. So new object, you're assigning new memory space to the array list which holds integers. Okay, then you system.out.println, you just print something and then add a character feed to a new line. Enter the number, and I'm going to enter a number, and I'm going to say that number is to find factor of. So it's very descriptive, the way int to find factor of, and it's very specific here. If you have seen scan.nextInt, everything is very specific. So we're going to do scan.nextInt. Basically, I'm going to tell the scan object, okay, go ahead from the console and get me an integer variable or an integer value from the user, and it's going to go ahead, get that value from me. It's going to wait blink there and then get it from me, and we're going to do this over here. Then you have a limit. So I'm not going to use this in our main while loop, because then I will lose the value of this number, and I don't want that to happen. So I'm going to put it in this aptly named variable called limit. So limit is the variable which is going to change, and yeah, it's going to change. So then I have an integer counter. So you might be imagining, why does counter start with 2? Because when you make the factors of something, you don't start with 1, right? If you have if you're going to make the factors of say 8, I'm not going to say 1 times 2 times 2 times 2, right? I need to start from 2, so that's why I'm starting from 2, and we're going to increment. Don't worry about that. I'll tell you what's happening. So while counter is less than to find factor of, and limit is greater than equal to 1. So what is this? Counter should be less than to find factor of. So basically the counter should not exceed the value of the number which I'm going to factor. So that is obvious, and I should not be able to explain that even further because that is pretty obvious. And then why am I saying that limit is greater than equal to 1? Because limit is going to change. It's going to eventually reach a value 0, and I don't want this to go on after it reaches a value 0 because that's redundant. You see, you don't want that to happen. If I'm saying that 8, I want to find the factors of 8, I'll do the first thing I'll do is 8 by 2, and 8 by 2 is 4, so I get 4. 4 by 2 again, 2 by 2 again, I get 1. But then I don't want that to go forward because see, 1 is already like the thing which I'm supposed to do is done. I got all the factors, and I don't want to go forward. So that's why I'm saying limit is greater than equal to 1. And if you read it, it'll be while counter is less than to find factor of, and limit is greater than equal to 1. So basically that's one line. Then I have, after this happens, I have the whole block which actually does the real job, which is I'm first going to check if limit, which is my number here, 2 factor of, percentage counter is equal to 0, which means that I'm going to check when if suppose let's assume this takes constant time. Okay, don't go ahead in that whole realm of algorithmics here. Stay with me. Limit mod counter is equal to 0, which means that okay, if I have, for example, limit is 8 and counter is initially 2, I'm going to say 8 mod 2 is equal to 0. Yeah, of course it is, because the remainder is supposed to be 0. Limit mod counter is going to give me the remainder of whatever that is. And then I'm going to say factor dot add counter. Factors. What is factors? Factors is the array list. Okay. I'm going to add the counter to the factors because that is our factor, the one which we needed. And then I'm going to say limit equal to limit divided by counter. So I'm going to actually divide it so that I can, move on with my life and move on with this program. Then I'm going to say if limit. So what happens after this is that 8 is still like, you divide 8 by 2 and you get 4. But 4 is still divisible by 2. So I don't need to increment the counter for any reason. I can just say limit percentage counter is equal to 0. Well, yes, limit is 4 and counter is 2. So yeah, then I'm going to continue. Which means continue means that I'm not going to execute any of this. Nothing. I'm just directly going to go up there and do everything one after the other. The same way I did before. And you might be thinking, isn't this an infinite while loop? Well, no. And why? Because the value of limit is changing and because limit is in the conditions. So once that hits the limit point, pun intended, you stop. Okay. Now let's take an example which gives us a false result for this. Suppose I go ahead with limit and I reach a value of say 1. So 1 percentage, 1 is not going to go into the loop anyway, but I'm going to still take an example. Let's take something more simple, I guess. Let's take 7. So 7 percentage 2. Okay, 7 percentage 2 is equal to 0. Well, no, because that's not how it is supposed to work. It's 1. The 7, when you divide 7 by 2, you get 1, right? And yeah, that's how it's supposed to be. So then I'm going to go into the else block and I'm going to increment 2 to 3. Then I'm going to check for 3. No, 7 doesn't go into 3 either. 4, no. 5, no. 6, no. But I'm not going to reach 7 ever because the counter will never reach 7. Actually, it will reach 7, but I'll not, and it will check, but it will fail. So, you don't really need to count it anyway. And that's about it. You go from 2 to 1 minus whatever that is supposed to have, and you stop the program. But there is a problem. Okay, there is no problem. This program is perfect, but I'm going to still tell you what the problem could be. Suppose you have a number, say 35, and you go starting, like you start from 0, 1, 2, 3, 4, 5, and you go up to 34. But the thing is that this program won't go up to 34. And you know why? Because I have some conditions here. I have this condition here, which will check. Whenever you go to, like, for example, take 36. Every time this loop will run, 36 will not be 36 anymore. It will be reduced. It will be by 2 or by 3 or by 4. It's going to be divided, and it's going to be less and less and less. So if you can imagine that, you can see that your counter is growing, but the number which you're like trying to find the factor of is getting lesser. So the number of steps to reach there are getting less. So we'll never reach 34. That number of steps does not exist. Even if it is a big number like 10,000, in the first step it's going to reduce to about 5,000. So you can imagine you never reach like 9,999 for 10,000 numbers. Or the number. So yeah, that's like this whole thing explained. If you don't understand this, take a piece of paper, execute it for yourself. It's very simple, and I didn't need to make such a big video for this, but I'm still going to do it. If a factor is empty, if there are no factors, then either the number is 0 or some prime number. So if it's 0, then factor is neither prime nor composite. That is, 0 is neither prime nor composite. Else system.out.println to find factor or whatever the number is, and it's prime number. So this is also a bonus for you. This is also how you can find if it's a prime number or not. Coincidence always looking out for you, man. Or woman, whoever is watching. Sorry. Else, you print out factors. And yeah, that's about it. Let's see if it runs or not. If it does, I'm very happy. If it does not, I'm not very happy. Okay, hey guys, it's not an exclamation mark over here. It's an equal to. I'm just stupid sometimes, so I make mistakes. But it's an equal to, it's not a exclamation, because that would be totally weird to, I'm already checking for the empty part. Okay, so let's run this program and see what we get. Okay, let's see. The number is, let's take an example for 7. Oh, 7 is a prime number. I never knew that. Okay, let's take the big numbers. Let's take 10,000. Oh, let's say 1,000. Oh, it works. Let's take a number, say 6. Oh, 2 times 3, it's correct. Let's take a number like 8. Let's take 8. 8 is a nice number, right? Okay, 2 into 2 into 2. So that's how you find the factors of some number. Okay, so thanks for watching. This is how I do it nowadays. Okay, I'm different now. Thanks for watching, guys. See you later. Yeah, I almost forgot. Subscribe, like, and share this video because a lot of people need to know how to make factors of numbers with a Java program and not with their hands. So yeah, trust me, it's important.